All right, everybody, we're almost there. We'll be starting in a minute. All right, so here it is. We are about to start. All right, we all know that tomorrow is our CXC exam, so we are definitely trying to get ourselves some tips um, for for the exam, right? I want to get in some tips for the exam. As soon as you log on, I want you to like the vid. I want you to like the video already. Subscribe to the channel if you have not yet subscribed. Share this, all right, so that people can actually watch what's going on. Also, leave a comment to keep the class lively and active. All right, I will start. It is now 3:01. We're definitely going to start our session right about now. All right, so let's go. So we're looking at, I'm going to try to go through to look at 10 questions. I'm going to look at a question at every stage of the exam. I want to use this as a guide as it relates to what it is that we really need to know as we go in. So our first question comes from number. So under numbers, this question states that 3.8 times 10 raised to the second power plus 1.7 times 10 raised to the third, right? We want to evaluate that, giving your answer in standard form. So what we want to do with a question like this first is just we want to work this out to see what we have first. Then we put it in standard form. So for example, let's look at this part. So 3.8 times 10 to the second really means 3.8 times 100, right? So 10 to the second is 100. So we're going to get about 380 for that part, right? Plus this part here, 1.7 times 10 to the third. 10 to the third is 1,000. So we could, just rewrite it like that. We're going to get 1,700. Then we're supposed to add this. So when we add this, we're getting 2,080. So remember, though, that we cannot submit this because the question says that the answer must be given in standard form. So what we're going to do is now remember the framework for standard form. It says a times 10 raised to the n, where a is a number that is less than or equal to 10, but it's greater than 1, right? So it's greater than 1, so it's going to be less than 10, basically, should say. And this is going to be any integer, right? So let us see. Basically, the point is at the back. We're going to try to get it after the first non-zero digit. So it's 2.080. And then we're going to multiply this times 10 raised to some power. And the case is that the number of places that we actually move the point. So if you check, we move it 1, 2, 3 places. So it's 2.080 times 10 raised to the third power. And this would have given us full marks right there. So as you go, like the video, everybody like the video. And what I want you to do is to work out the questions as you see them and submit your answers, all right? So that's question 1. We were dealing with standard form. For question 2, we are looking at a composite fraction where we have a half times 3/5 as a numerator, and we're going to divide this by 3 and a half. All right, so let us take the the numerator first, right? So we're going to deal with the top part. It says, so for the numerator, what we have is a half times 3/5. Let's work that out. Remember that when you multiply fractions, it is very simple. The top by the top and the bottom by the bottom, if there's nothing to be canceled. So 1 times 3 gives us 3. 2 times 5 gives us 10. So that is the part for the numerator. Now, for the denominator, this can be rewritten as 3 times 6, 3 times 2 is 6 plus 1. This is 7 over 2. So basically, what we really have to work out finally is 3/10, and you're dividing this by 7 over 2. Remember that when we divide, we change our division to multiplication, right? So we have 3/10 times 2 over 7. Let me fix that. Times 2 over 7. So we change our division to multiplication, and then we're going to reciprocate the fraction that comes after the multiplication. And from here, they did say in this lowest form. So if there's anything that can be canceled, for example, 2 into itself, 1, 2 into 10, that's 5. What we're left with is 3 times 1 at the top, which is 3, 5 times 7 at the bottom, which is 35. So we're looking for 3 over 35 in its lowest form, as you could see there. So that's the lowest form of what we have right there. So that's like the second part of what you're expecting to get. You're looking for anything on the numbers at number 1, along with some percentage and stuff like that. So here comes the percentage part. So it says here, John bought a car for 65,000. If the value of the car depreciates, so this is the key here that we're looking at. And when something depreciates, we're losing value. So it depreciates by 8% each year, right? How much will the car be worth at the end of year 2? So there are multiple ways we can get there, but I'm just going to go through this just a standard way. So if you're losing 8% each year, right? So basically the original price is 100. You're losing 8%. So if you take that 8 from 100, you're going to have 92%. So every year the car is going to worth 92% of what it was. So in this case, the depreciation is going to be 8. So we're going to be working on what is 92% of the thing right now. So this is for year 1. So year 1, we want to find 92% of 65,000. All right, that's one of the ways. There are multiple ways that we could do it, but I'm just working it this way. So 0.92 times 65,000, and we're left with, this is 59,800. So after the first year, the car actually value 59,008. But the question says at the end of the second year. So this is year 1 here. So we're looking at the end of year 2 now. Now, remember again, it is still depreciating by 8%, right? Which means that we're looking at a new value for the car right now. This is the value of the car right now. We still will find 92% off this because it is, so this is what it is worth now. And then we're taking off 8%. So we're dealing with 92% of what is left right now. And remember, it's not 65,000 anymore. The car is now valued at 59,008. And then after this, we'll see where we reach. All right. So let's work that out. Make sure that we're not making any error with the numbers. So after the second year of depreciation, we're getting $55,016. After 2 years, this is what the car is now worth at the end of that period, right? So we're dealing with depreciation right there, right? And remember, when you're dealing with depreciation, value is being taken off, right? And there are multiple ways you could do it. As I said to you, you could have found 8% and then subtract it each time, all right? But also you can interpret the losing of 8% as you're left with 92%. And as long as you're able to see that way, you're good to go and you're good. So let us take a look at the next question. All right. So for this question, it says here that the table below shows the results obtained by a student in a CXC mathematics examination. The maximum mark for each paper is given in the third column of the table. So we're seeing where this is the maximum mark of the paper. We're seeing these are the papers. We're talking about paper 1, paper 2, paper 3, right? Going right there. And in the middle, we have the percentage that was obtained. All right. Now, here's a question, though. Here's a question. Determine as a percentage the student's final mark for the maths exam. All right, we want to know the final mark for the exam. So being that we got the percentage, we're going to relate the percentage each time we're going to find it. For example, for paper 1, and I could just say paper 1 here, the person got 55% off 30 marks. So we want to work out that. So 55% of 30 marks, you put this on your calculator, and you're going to get 16.5. So what this is suggesting here, that the person got 16.5 out of 30 for that paper. Let us take a look at paper 2. For paper 2, we're told that this student also got 60% out of the 50 marks. So we need to know that mark. So it's going to be 60 over 100, and you want to multiply this by 50, right? So you want to work that out, and we're getting 30 for that. So this is going to give me 30 marks. And it means that this person got 30 marks out of the 50 for paper 2. Let us check the last one, paper 3. For paper 3, we got 80% of the 20. So we're talking about 80%. Hold on. 80% can be represented as 80 over 100. And you're going to multiply this by the total number of marks, which is 20. And this gives us 16. All right, so 16 here. What we want to do now is to total what the student got. So the student got 16 or 16.5, then 30, then 16. Let's add these up all together. So 16.5 plus 30 plus 16, and I'm getting 62.5. So the student got 62.5 out of 100. So we are supposed to represent 62.5 out of the 100 marks and then change it to percentage. And as you could see, 100 cancel itself. That means the child got 62.5% overall, right? So what we want to do with questions like these is that you want to read the question first, right? You want to read the question and make sure that you understand what is being asked. Look at what they're doing and then respond to the question very simply. So as I said here, that this person got 62.5% from that test. Let's go to the next question. Let's see what's coming up next. All right, so question 1 would have been finished. So right there would have easily captured 9 marks from that. Let's see what a typical question 2 looks like. So question 2 is always algebra, right? So here is it saying that, hey, make x. So we are asked to make x the subject of the formula, right? We want to make x the subject, which means that we want to transpose and isolate x. So when you make something the subject, we're talking about we want to isolate that thing. So we want to isolate x. So we're going to do 2 things. 1, we're going to do inverse operation on anything that we desire to remove and balance the equation. Anything we desire to move, inverse operation and balance, and that will take us out. First move, there are many first moves, but I intend that, okay, I want to remove. So it's up to me, right? I want to remove the 3p. So it means then I'm going to subtract 3p from both sides. So if I rewrite this, right, I'm going to have y minus 3p y minus 3p, right? And that is going to equal to x over 5. We're almost there because this positive 3p and the negative 3p would have canceled, right? Fully. Now, what we're going to do here is that we want to multiply both sides by our 5 in order to get the x to be standing alone, because that 5 is dividing. The inverse of division is to multiply. So we multiply by your 5, and then over here, I'm going to use a parenthesis and then multiply by 5. What I'm looking at is 5, open bracket, y minus 3p is equal to x. Or you can flip it and say x is equal to 5, open bracket, y minus 3p. There is no desire to distribute the 5 inside. It is okay as is. But if you want to distribute it inside, that's up to you. But it is fine as this right now, right? Now, so we're going. So remember the key thing here, inverse operation. So the key thing whenever you're doing any form of transposition is that we're doing inverse operation. And whatever you do to one side, you do to the other side. We call it balancing. So as long as we're doing that, then we should not have any problem as we go from one stage to the next. All right. So that is an easy 2 marks again that we could pick up. Now let's take a look at this. They do give quadratics here to be solved. They can give simultaneous here to be solved. But what I have here is a quadratic. Whenever you're solving a quadratic equation, it must be equal to 0. And we have already gotten the system like that. Now, there are various methods that we can employ to solve, but always check to see if you can factorize first. It's a little bit quicker and easier, and time is of the essence as well. I do realize that I can factorize this to solve, so I am going to factorize this. What is my highest common factor here? My highest common factor is just x. So I'm going to take out x and open the bracket. Then I'm going to divide x into 2x squared. I'm going to be left with 2x. Then I'm going to divide x into minus 9x. I'm left with minus 9. And this is equal to 0, right? So there it is. So we have two things multiply, and the result is a 0. Now, we wouldn't know which one is a 0, but we definitely can draw a logical conclusion by saying either the first one, which is this, so I could say x is equal to 0. If x is not a 0, well, 2x minus 9 is 0. And from here, what we want to do is to solve ordinarily. So I'm going to add 9 to both sides. Adding 9 to both sides, I'm left with 2x is equal to positive 9. I'm almost there. My intention is to isolate the x. So I'm going to divide both sides by 2. And then let's take a look. X is equal to 9 over 2. All right. So definitely those are my responses. I'll highlight them. In one instance, x is equal to 0. And the second response is that x is equal to 9 over 2. Definitely, if you want to put 4.5, that's up to you. But 9 over 2 is actually a very good and acceptable answer. And we're good to go with that. Here it is, as you could see, it was just 2 simple marks for that. So we execute, making sure that there is no error as we flow. And we're good to go with those sort of response, right? Good to go with that. Let us take a look at what the next question is about. All right, let me read. So I'm going to read. It says here that a farmer wishes to enclose a rectangular plot, right, with a wire fence. The width of the plot is 3 meters less. All right. So we want to note important details. Like whenever you're doing the questions, you want to note important details. For example, this is so important. The fact that it's a rectangular plot, very good. And then it says the width is 3 meters less than its length, L. All right. So let us say I drop a quick rectangle here. All right. So what we want to do is to remember that the length, right? The length is given as L, right? But the width is 3 meters less than L. So what it means then, you're going to have L minus 3 because it's 3 meters less than L. So you take it from it. Now, the question is saying that given that the area enclosed is 378 square meters, show that L squared minus 3L minus 378 is equal to 0. We are going to embark on the idea of area. How do we find the area of a rectangle? Area of a rectangle is always equal to my length times my width. And that is why the question was actually designed around that idea right there. So what is the length that we're dealing with, right? The length, let's set it up. So the length, so I'm going to put, so area is equal to length times width. So let me write this. So my length is equal to L times L minus 3. That's my length times my width right here. Take a look. Length times width. And what will it yield? It's going to yield the area, which is 378. We were given that the area of the entire thing is 378. Therefore, this must be equated to 378, right? From here, what we want to do is to do our quick distribution. So I'd advise that we're going to distribute L to the L and then L to the negative 3, and then we see what we have. So let us go ahead and do that. L times L will give us L to the second power. L times negative 3 is negative 3L. This is equal to 378. As you could see, we're almost closing down on what they wanted because this is what they wanted. So in order to get it the right way, we're going to subtract 378 from both sides, right? So that there is a 0 on the right side, just as how they had requested that we set up what we have. So let us go ahead and rewrite this. So we're going to have L squared minus 3L minus 378. This is equal to 0. And as you could see, we would have shown exactly what they want. As soon as we put all of that together, make our move, we are right there. So there it is that we would have caught what they wanted, and then we move on. Now, another thing, if you're doing this and you do realize that, hey, you realize that you didn't get what they want, you need to just double check your working, because normally when they ask you to show, it really is so. So in other words, then we already know that it should look like this. And if at all I am not getting it looking like it, it simply means that I made an error and I need to just double check it as I go forward. All right. So with these sort of questions, I kind of like them because you already know what you're looking for. So it stays there as a guide as you walk yourself to. All right, let's take a look at this. This looks like it's a variation question. Variation is a topic that comes a lot right here at number 2. This is the only place it comes, right? So let's read the question and then put it in the right context and then see if we could go through. It says, the force F applied. So the force F applied to an object is directly proportional. This is key. Underline this right here, because this is what is going to dictate the formula for this question. So it says it's directly proportional to the extension E. So we're dealing with F, we're dealing with E, right? Produced by that object, no problem. Now, represent this information as an equation in terms of F and E and an appropriate constant. They want us to use K for the constant. All right, so we're going to have a F, a E, and a K in an equation right now. Context of the question, we're dealing with direct proportion. So with direct proportion, we were told that F is, this is the proportional sign for those who does physics. Not like you need to write it, but I'm just saying, so F is directly proportional to E. This is how it is written. But as a formula with an equation, it's going to be F is equal to my constant times my E. Remember, though, that this way of writing this is only because we are handling direct proportion, right? When it is inverse, that's not the case, right? When it is inverse, the second variable becomes a denominator, right? So F is equal to KE is what they want to see right here. I believe this may just be 1 mark. Definitely, that's a 1 mark response. How are we going to use this now? be advised that this will be used to solve every single problem for this question, because the narrative of the question had forced us to come up with this. And this is the formula that will dictate the pace for every question in this variation. So let us now go to the second part of the question, where it says, the incomplete table below shows corresponding values of F and E, right? Corresponding values for F and E, I will highlight. This is my E row. This is my F row, should say, and this is my E row down here, right? So we want to pay attention to the rows, right? Let us see what they want. So they're saying using the equation obtained above, which is this. I'm going to write it back that F is equal to KE. K is the constant of variation right here. Remember, we said that. What we want to do is to determine the value for X and Y. Now, let us start off. What is X? X is a value that is an E value that we don't know, right? Now, before you get there, I would advise you that finding K is most important. K is the constant. So in order to find K, we have to look at any case where we have an F and an E value like this. Or, you notice I said or, because you can use this situation or this situation to find a value for K, and then you move on. So this question is rather very interesting because we have two cases that could have helped us to find K. A lot of times it's only one, but I have two, and I'm not going to show you why both work. I'm just going to pick on anyone. So anyone work. I'm going to take the first one. So my intention is that in order to solve any variation, we need to know the value for the constant of the variation. And in this case, your constant is K. Now let us list what we have. We're going to take the known F, which is 8. So when F was 8, E was 0.2. So we're taking two things that we know happen already, and we're going to manipulate that to find K. Utilizing this formula, F, let me put it at the side. Let me put it at the side. I'm going to put it all the way to the left. So I'm by the left. So F is equal to KE. Remember, though, that F is equal to 8 and E is equal to 0.2. They happen together. I can now substitute. So I could say 8 for F is equal to K, I don't know that yet, times E, which is 0.2. So in an effort to find my K, right? In an effort to find K, all I'm going to do is just divide, right? We are going to do ordinary division. Let's go. We're going to divide both sides by 0.2 so that this K can stand alone. So when we divide this by 0.2, let us work this out right about now. 8 divided by 0.2, we're getting 40. So 8 divided by 0.2, I'm getting 40 for K, or a lot of people may say K equal to 40. Doesn't matter. So K is equal to 40. I rather agree. So K is equal to 40 right there, which is what we definitely need. All right. So K is equal to 40. Let's go. Now let me rule up my thing now. Now I'm going to do a two-part thing here. Now that I know that K is 40, please remember what K is. K is the constant of variation, which means that K doesn't change. So while my X values and my Y values are changing, the K will remain constant, and it is the mediator for my variation. So let us get into it. So now let's write back the fact that K is equal to 40, right? Now I'm going to try to find my X. So X, I'm going to write it like this. X is an E value that I don't know yet. But at the same time, if we look in that column, right? On top of the X, we realize that the F value was 25. Excellent. Definitely there's going to be just one unknown at a time. So we could set up back our formula by saying, remember, that F is equal to KE. F is 25. Let's substitute. 25 is equal to K. K is 40 times E, right? KE. Now, all we're going to have to do is to find E. But remember, E is now X. So let me write X for it, right? Let me put it in a parentheses right here beside it, because this E value is called X. So I'm going to put it there as X so that you could see the point. Now we're going to divide both sides by 40. So let us divide that. 25 divided by 40. And I'm getting, let me divide this out. Work with me, make sure that there's no error being made here. So 25 divided by 40 will give me some 0. Well, it's up to me. This is an answer. But so X is equal to 25 over 40. If I should divide this out by 5, I'm going to get 5 over 8, or it's equal to 0.625. It terminates itself, so I could work with it, right? So whichever one we want to drop here, 0.625 or 5 over 8 is acceptable at this moment, and that is my X value. So I'm going to highlight it for us, that X is equal to this, right? Or you could say 5 over 8. It's up to you. Now, let's look at the second part, where we want to find Y. So let me clear the table here so it's a little bit clearer, less distraction on it. So let's highlight the column that we're handling now. We're handling this column, where, as you could see, Y is not known, right? Y is an F value. So I could say, listen, there is an F value that is called Y that I intend to know what it is. At the same time, the E value is equal to 3.2. K, as the name suggests, is the constant of variation. And while everything changes, it remains the same. So let us now push through as we go. Remember the formula that dictates the pace for this question. It says F is equal to KE. It doesn't change until the narrative changes for another question. What is F? F is a Y value that we intend to find. What is K? K is the constant. It remains 40 times E. What is E? E is 3.2. Let us work that out. 40 times 3.2 is going to give me about 128. So as you could see, my Y value is 128. Let me highlight that a little bit right here. That's my Y value right there. So variation, it's a nice question. There is one formula that will actually dictate the pace throughout as you go. And it's just that you have to make sure that you write it properly. There is a difference between inverse or direct variation, right? So look back over your notes as you go for your exam tomorrow. Let's see what pops up here. All right. So we're looking at this question. So this question is a Trig's question, and it says the diagram below shows a right angled triangle with sides A units, B units, and C units. So I'll highlight what we were given. We were given that we have A units there, B units there, C. These are the lengths of these sides, basically, right? It's a right angled triangle. We're noting key things of this. Now let us see what else that we want to look at as we go, right? So the question says, using the diagram, express C in terms of A and B. Express C. Come on. So we're asked to express C in terms of A and B. So what we want to do here is to make sure that we're not making any error. Let me drop this right. I could drop this right here. C. C is the longest side. So then I could start off by saying, what do I know about a right triangle? Well, we're dealing with three sides. I will employ the Pythagorean theorem. It does suggest that the longest side, which is C in this case, and the longest side is across from the 90 degrees. So it says C squared is equal to, let me write this a little better. Looks a little bit crappy right there. C squared is equal to A squared plus B squared. So that is C squared. But they didn't ask us for C squared. The question said express C. So at this moment, you're going to have to take the square root of both sides, right? So C is actually the square root of A squared plus B squared. Now, if you do, I think this might be so one more question. Now, if you do not take the square root, I don't believe you're going to get that 1 mark. You have to nail it, right? You have to nail it, because following the instruction is very important. Express C. right? And when you started off with c squared. We started off with c squared equal to a squared plus b squared. And so c squared is not c, and you want to make sure that you're not falling into trap here and run off, right? Give the question what they desire, all right? Very straightforward and simple. Now, let's keep going. So we have a c here. I'm going to write it on the line that c is equal to the root of a squared plus b squared. The Pythagorean theorem, that is what we're dealing with right there. Now they're stepping it further. The question went further and the question says this. It says, write in terms of a, b, and c an expression for sine of theta plus cos of theta. All right, no problem. So we want to deal with sine of theta plus cos of theta. Let's clear this diagram up so we could look at it. Let's clear it up so we could look at it. Right. So the sine plus the cos. Take a look. The angle, I'm going to put it in green. It's right here. We know that. So right now we're dealing with this key thing. It says so ka tower. You want to bring this into context right here. You want to bring this into context here. Sine deals with the opposite side from the angle across from all the way across. So this is the opposite for sine right now. And this is the hypotenuse right there. So basically then here, sine theta is going to give, I'm going to write it right here. So sine theta is going to give me, take a look, A over C. Sine theta is A over C, right? Plus, let's go back. We're going to look at cos theta. Let me take this off so we could look at cos theta. Remember, cos, as you could see here, is dealing with the adjacent side to the angle and the hypotenuse. Adjacent is next door. And remember, when we say next door, we will never confuse next door with our hypotenuse. The hypotenuse is very unique, and we don't want to confuse that. But next door is right here. So it's going to be B over C, right? So this is my adjacent side right now to this angle theta. So it's going to be B over C. Let's write it. So it's B over C. There it is. So they asked us to write in terms of A, B, and C, that, right? So we have that. We can simplify this. Right now, we can simplify this. As you could see, let's take a look. So what we really have here is adding fractions when your denominator is actually the same. So we have same denominator right there. So if I have same denominator, I'm going to keep it and I'm going to work with my numerator. So basically then I could conclude that sine theta plus cos theta is equal to A plus B over C. And there it is. You would have gotten 2 marks to execute your idea right there. So as you could see, looking at this question here, it is just testing to see how much you could apply yourself. Are you willing to look on the situation and just give birth to the idea based on all the things that you would have learned over your 5 years or whenever you have done the course? So never look at a question and fade away. Always apply idea, because the ideas are always given to you. All right, let us take a look at the other question. We're in part 2 of this. All right, so the second leg of the question says, using the results from I, A, and B. So those 2 results, I could write them here. We started off by saying C squared is equal to A squared plus B squared, right? We started off with that. We also had A plus B over C. We had these looking on, right, while we were dealing with the question. So let us see what they want us to do. They're saying, can we prove that sine theta squared plus cos theta squared is equal to 1? We want to show that. So remember, though, that our sine theta, I'm going to write it here, was equal to A over C. Our cos theta was equal to B over C. Remember, we got those. So in this case, what we want to do is to represent very simply. Let us represent. So sine theta, A over C. So I'm writing my sine. Remember, I'm going to put it on top. So this is sine theta, and we're talking about sine theta square. So I'm going to square that. Now I'm going to put beside it the cos theta square. So you could see what I'm doing. This is B over C, and I'm going to square that. So there it is that we set up. When you square this, what you're really getting is A square over C square plus B square over C square. This is what we're getting right now. Now, in an effort to prove that this is one, there are a number of things that we can do. Now, let us simplify this. Again, my denominators are the same. They're both a C square, which means that I have C square here. What do I have as my numerator? I have A square plus B square. Now, at this stage, I'm gonna recall something that I had. So I'm gonna say, remember now, I'm gonna say, recall this. I want us to recall that, come on, you want to recall that C squared is equal to A squared plus B squared. I could substitute it two ways, right? I could substitute these two ways. I could put, so I'm gonna just write it quickly. I could put A squared plus B squared for C squared. I could. So in other words then, right now, this here is the same thing as C squared. So I could say C squared over C squared. And anything divided by itself give you 1, hence the proof. We have just proven that. Or secondly, if you wanted to do it the other way, take a look. You could have said, okay, I have A squared plus B squared. Remember, C squared is here. C squared is A squared plus B squared. So I could put C squared as A squared plus B squared. And anything divided by itself still give you 1. So whichever way you want to approach it, you would have still gotten that same response, right? So conclusion here that cos, let's just write our conclusion here. So we could see that sine theta square plus cos theta square, it does give 1. We just prove it 2 different ways. In an exam, you only need to knock it one way. Please do not waste any time. This is just for instructional purposes that I actually landed it like that, okay? Let us keep rolling. Let's roll. All right, so a typical question 4 could be a function question. It says here, given that h of x is equal to 3x plus 3 all over 5 minus x, we want to determine, 1, the value of x for which the function is undefined. The moment we speak of a function being undefined, it's going to be a rational function, one in which the denominator cannot be a 0. There will have to be some variable in our denominator. So we're going to take the denominator. We're going to equate the denominator to 0. We are saying that we want to find the value that would have caused that problem. So definitely, what value, if I insert it where x is, I'll get a 0. We could just solve this easily, right? So this is a easy solve. So you could see if I just add x to both sides so that I could have a positive x, then 5 is equal to x, or you could say x is equal to 5. In other words, if x is equal to 5, the function is undefined. That is the value of x that the function cannot actually take, all right? You won't be able to function with that there, all right? Second question says that we want to do the inverse of, so let me want to do the inverse of h of x. So let me just quickly write what h of x is. So h of x is equal to 2x plus 3 over 5 minus x. So this is h of x. But what we intend to do is to find the inverse of h of x. In a response to find the inverse of h of x, I'm going to start off the problem by saying that. I'm going to say, let y equal h of x, right? So I'm going to let y equal to h of x such that, so I'm now going to replace my h of x for y, right? As y. So I'm going to say y is equal to 2x plus 3 all over 5 minus x, right? So there it is that we have that. So there are 2 steps that one needs to take if at all we're going to do our inverse. The first step is that we want to switch x and y, right? So wherever x is, we're going to put y. Wherever y is, we're going to put x. All right, so let us switch x and y right about now. So I'm going to have x is equal to 2y plus 3 over 5 minus y. So wherever the y is, we're switching that for x. And then the second step is that we want to transpose to make y the subject now, right? So the intention now, after you have switched, is that you want to make y the subject. So the bottom line here is let us execute our algebraic skills right as we go. So here it is. I'm going to multiply both sides, right? I'm going to multiply both sides by 5 minus y. Over here, 5 minus y. 2, I'm going to put it in a parenthesis so you could see. So I'm multiplying both sides by 5 minus y. On my right side, 5 minus y would have canceled itself. I'm getting rid of the fraction so that I could work easily. Now, I'm going to have to distribute here. So I'm going to distribute here the x inside. I'm going to distribute the x. So when we distribute, I'm getting 5x minus xy, which is equal to 2y plus 3, right? So we have that right there, 2y plus 3. So what we want to do, my bad, what we want to do here, though, is to remember the context of the question. Context of the question is that I want to collect my y's on one side. So let us say I want the y's on the right side. I determine where I want the y. It doesn't matter. But let us say I want the y's on the right side, right? So right now, all we're going to do is to say, all right, let's add xy to both sides. Why am I doing that? I am adding xy to both sides because I'm collecting the y terms so that they can be at one place. So let us write another step. So we have 5x is equal to, this is going to go. So currently, I could just say this is xy plus 2y plus 3. I'm going to take a second step. So the second step is that I need to remove this 3. So I'm going to subtract 3 from both sides. Let me put it up here now. Because I subtract 3 from both sides, I'm left with 5x minus 3, which is equal to xy plus 2y, right? That's what I have right now, right? Remember that the intention is that y is what we're focusing on. So I'm going to have to factorize out the y so that I could have one y dealing with, because I'm looking at y here and y there. They are not like terms, so it's not a case where you could say you could add them. You cannot. So I can factorize out the y. So I'm going to have x plus 2. Right, and here we go. We're almost done because the intention is to isolate the y. So I'm going to subtract, I'm going to divide both sides by x plus 2, x plus 2. So you could see now y is all alone, right? So y is all alone. And what we're looking at is this. We could say y is equal to 5x minus 3 all over x plus 2. Remember what the question really wants. The question asks us for the inverse of x. We don't want to leave the question like this because we're not done. So we're going to answer the question. So in a response to the question, I'm going to say the inverse of x, the inverse of h of x is equal to 5x minus 3 over x plus 2. Conclusion, right? Remember, respond to the question, give them what they want, and then we go. So basically, that is how we want to approach this question. And this is like the worst case scenario for an inverse question. It doesn't get harder than this. This is the hardest one where there are 2 of the variable that you want. Like you're going to end up with 2 y's and you have to factorize out. But every single time it occurs, the moment the terms are not alike, you're going to have to factorize. Remember, the terms are not alike. And I'm referring to, I could just point to it because it is very important. When you will write here, these are not like terms. One is a xy and one is a 2y. They're not alike. So because of that, factorization will be employed as you try to execute. All right. Now let us keep going. At number 4, we could look out for coordinate geometry as well. All right. So let us see what goes on here. It says the graph below shows a straight line intersecting the x and the y axis. We're looking at it. So I'm just going to highlight the intersection. So this is the intersection of my x-axis, and that's the intersection of my y-axis right there. Just to highlight the idea so that we could see. Remember, guys, if you're just coming on, please like the video, share it to your friends right now as well, right? And drop a comment as we go. Subscribe to the channel as well, all right? So let us go. Let's see what the first question says. The question says, using the graph, determine the gradient of the line. All right, so we want to determine the gradient of this line. All right, what I'm going to do is just to put on some labels here. Let me put on some labels quickly. So in terms of numbers, right? So you would see that this is 1, this is 3, this is a 5, this is a 7. So I'm just putting on some numbers so that you are okay. This is a 1, this is a 3, this is a 4, this is a 5, so that you could see a flow of ideas as it goes towards where we're going, right? Now, let's handle the question. I could use these 2 points to do my slope. So at P, right? So at P, let me see if they had given, all right. So let's write this. I could write it right here. So one of the points would have been 0, 4, right? So that is this point up here. And then there's another point here, which was 5, 0. We are going to use these to actually give us the gradient. So we're going to label, as you all know, x1, y1, and then x2, y2. So there it is. We would have labeled those. And then now remember the gradient formula, right? Here comes the gradient formula for those who do not remember. CXC does not give you this formula. It says y2 minus y1 over x2 minus x1. Let us keep going. y2, 0 minus y1, 4 over x2, 5 minus x1, 0. Let us go. 0 minus 4, minus 4. 5 minus 0, 5. My slope is negative 4/5, right? So technically, what we're saying is we have a negative 4/5 as my gradient. And we definitely saw that, because you saw that the line was going down from left to right. So that's a negative line. We knew it's a negative gradient, all right? So there it is. We have the gradient of that, picking up the 2 points that were given in the question, understand how to read coordinates, pick up our x and our y-intercept, and then we use it to solve our problem as we actually go. All right, let us keep going. So they want us to write the equation of that line. All right, so in a response in writing the equation of this line, it's 1 mark, right? You're not going to do any calculation now, because if I have the slope and if I have the y-intercept, I'm good. And definitely we saw we have the slope. And I'm going to just highlight what the y-intercept is one more time. Here is the y-intercept. I'm going to put it in yellow right here. The y-intercept is at 4 right here. The y-intercept is at 4. The y-intercept is at 4. Let me take another look right here. That's my y-intercept, right? So if I have my y-intercept and if I have the gradient, then I'm done. So here it is now. I'm just going to write my m value, which is my gradient, is negative 4/5. And my c value, which is my y-intercept, is 4. What is the equation of that line? Y is equal to negative 4/5 x plus 4. It's a 1 mark question, which means that you could easily pick up the values and just go, right? So right there, we just did that, right? Take a look at it and let us see what else they're looking for. Let's see what else they want. Again, guys, keep sharing this video. Like, subscribe, share, right? Let people come on. Exam is tomorrow, right? Wrapping up. All right. Now, the question went further and it says, determining the equation of a perpendicular line that passes through P. All right, so this is actually a very nice question. What is the relationship between perpendicular line? So I'm just going to drop it here. I'm just going to write it here in a text form, that when lines are perpendicular, right? So I'm just going to say, when lines are perpendicular, right? One gradient is the negative reciprocal of the other, right? So that is key information that we need to at least know, right? So if I know this piece of information right there, that when lines are perpendicular, one gradient is the negative reciprocal of the other, all right? Which means that, take a look. For the first line, we have, let me just call this M1. That's the gradient that we got from the first case. We got this. M2 will be for this line now, right? So this is the second gradient. I'm saying, what does negative reciprocal mean? Reciprocal means to flip upside down. What does negative mean? Negative means to change the sign. We're not saying negative mean that it will end up being negative. No, we're saying it's going to be the opposite to what it was. That's what this really means. So let us invert this. So the new gradient will be 5 over 4, and it will be a positive one. But you know that we don't write plus in front of numbers. So it's just going to be a positive, right? So you flip it upside down and you change the sign, all right, for the second gradient. So there it is that we got that. Now, we're going to need something very important now. But it says it passed through P. Now, where is P? We want to take back a look at our graph, because all we need when we're doing these problems, right? All we need when we're doing these problems, let me see. All you need when you're doing these problems is a slope and a point. So we have the point, right? We have the point, all right? So we have a point that the line passes through, all right? It passes through 5, 0. So I'm gonna, so right here, they did say it passes through P. So I'm gonna take this, where are we? So I have, for this question, I have my slope, which is 5 over 4. I have a point that it passed through, and that point is 5, 0. Now, remember now, for this, this is X and this is Y, okay? You're going to have to apply yourself to the case, one in which you're going to have to try to find for yourself the Y-intercept. It wasn't given. But there are countless ways to do this. I'm going to do this one of the ways. There are a number of ways to do it. So I'm going to set it up in Y equal to MX plus C format. So I'm going to try to find C right now, right? So I'm going to try to find C, and when I'm done, I'm going to combine the slope and the intercept and write the equation. Let's go for it. So we're going to substitute Y, which is 0 here, which is the point, right? M, which is 5 over 4, X, which is 5, as you could see, X is 5 plus C. That's us. Let's relax and take a look at what we got, right? So what we got here is 0 is equal to this. So what we have here is actually 25 over 4 plus C, which means that all I have to do is to subtract this from both sides, right? So if I subtract 25 over 4 from both sides, I'm ending up with my C. So let us write this, that C is equal to negative 25 over 4. Remember now, I have my y-intercept, right? I have my y-intercept right there, which is negative 25 over 4. Now, so all I'm going to do, I'm going to put it in this box. Since I have my, let me use the different marker. Since I have my slope and my y-intercept, the question is as follows. Y is equal to slope, 5 over 4 beside X, my y-intercept. We're done. That's it, because they never gave a specific way in which we need to represent, because there is what we call a point slope form. This is actually a slope and an intercept form, right? And we have standard form. The question just said write the equation. So I chose to write it in slope intercept form, where I'm able to identify the slope and the y-intercept. And this is good to go for your 2 marks. And we would have completely completed number 4 right there. All right. All right, let's go. The truth is you could represent this other ways, right? You could, it's all right though. What if you, but you won't get any extra marks for that. And by that I say this, like it depends, because some people might have set it up and work it out. And if you multiply everything by 4 to get rid of the fraction, right? Let us say you don't want to have any fractions. I'm just saying you multiply everything by 4. Then this 4 cancel that, this cancel that. it could have been written as 4 times y equal to 5x minus 25. This is also another way you could write the equation. But it's not like say you're gonna get marks for that. There is no mark given for that. So you're good. I would have just left it like this and I'm gone. All right. All right, let's keep going. Here we are. All right. I think we're at the number 5 question. All right, so this question says here, I think this is a number 5, it was rubbed off. So it says here, a survey was conducted, all right? A survey was conducted among 48 persons to find out what mobile network they use. The table below shows the results of the survey. So we have the mobile network here, we have the number of persons. So we have Wiretech, Digilec, OFO, and others, right? And then the numbers in terms of the frequency for each was actually given. All right, let's get into it. All right, so sorry about that. The question says, if this information is to be represented on a pie chart, right? I'm looking if I left out anything. Okay, what is the angle for the sector that will represent O4? Now, the moment we say pie chart, we're thinking of a circle, right? A pie chart is a circle, and they're saying what degree of the circle would O4 be? Remember, though, that the total degree of any circle is 360. So this is key. And we're dealing with a pie chart, like a pizza. And it's like when you cut up that pizza, you pull out a slice of a pizza. O4 will be one of those slices. So let us deal with the O4 sector. So for O4 is actually 10, but you need to know 10 out of how many. So we're going to have to total the number of, so we have, let's add up that to find out. So you want to add up these, so that you could have a total in terms of how many persons you're dealing with. So it's 20 plus 12 plus 10 plus 6. And that looks like I'm getting a total of 48. So I'm dealing with 48. So if I'm going to represent O4 is 10 out of the 48. And then I need the degree for it. It's going to be times 360. Why times 360? Why not percentage? Because the question is not about percentage. The question is about the degree that we want to put in here. So when you work this out on your calculator, that times that, we're going to get 75 degrees. Make sure you're double checking for me. 10 divided by 48. Let me double check again. Then I'm going to multiply that by 360. Definitely 75 degrees. And that's for O4. You would have gotten 2 marks right there. So remember though, that when we're handling these, the main thing is that we want to understand that a pie chart would be out of 360 because that's a circle, right? That's a circle graph right there. All right, let's keep rolling. Let's keep rolling. All right, so here it is. I use the circle below, the radius shown, represent information in the table above on a clearly labeled pie chart. Now, what it simply means is that I'm going to have to take the time to find the angle for the others because I don't have it. I have O4 as 75 degrees. I'm going to have to work out Wiretech, Digilec, and others. I'm going to have to work out those to get their percentage. Then you can represent your pie chart. So 20, so Wiretech is 20. So let us work out Wiretech. Wiretech is 20, so it is a Wiretech. I'm working this out on the side. I think it's a H. Give me a second. Wiretech is going to be 20 out of the 48, and we want to multiply this by 360. So let's go for that. 20 divided by 48 times 360. That's 150. So Wiretech is 150 degrees out of it. Let us look at another one. Digilec is 12 out of the 48. Come on. 12 out of the 48. We're at Digilec. Digilec is 12. So it's 12 out of the total of 48. You multiply this by 360. And as you could see, this is a quarter because 12 out of 48 is a quarter. I'm getting 90 degrees right here for Digilec, right? 90 degrees for Digilec. And let's go for the last one that represents other. I think it was 6, but we're looking 6. Other is 6 out of the 48. It's a half of this, so it looks like it's 45. Well, let us check it. 6 out of 48 times 360. And this is the angle representation for others. So 6 divided by 48 times 360. Hold on. 6 divided by 48 times 360. All right, I'm getting 45 degrees. Now, with this information, we're gonna put on, so I'm gonna put O phone here since we got it first. Just put O phone here. I think it was a 75 degrees that I got. So what we want to do then is to put this on. That is all. So we work them out. You want to put them on. That's all. So O phone 70. So you'd use your protractor to measure these angles. You use your protractor 75 degrees. You measure that. This is about 75 degrees. You measure. And you're going to write your O phone here. This is O phone. Right? So we ticked off O phone. The next one we want to tick off right there is that you could tick off your anyone, it doesn't matter. What if you want to tick off your 90 right there? You could make a 90, well, you could make a 90 here if you want. This is a 90 degrees here. That's the 90 right there. Hold on. All right, so we tick off a 90 there. And that was for Digilec. As I said to you, you use a protractor and measure your degrees, right? Measure your degrees, and then you're just gonna complete it right there. And then 150 somewhere about here. This is 150 degrees. I could just write it here. And this 150 degrees was for wire tech right here. And then lastly, this is 45 degrees, and this was for other. There you go. So we're expecting you to work out the degrees because it's a circle is dealing with degrees. And one has to remember that the total degree is 360. So you could, a fraction of it, just a fraction of the total, and you just keep working. It's not a big deal, but you have to do the work, right? Easily. All right. So there it is. You're expected to do that. You get 3 marks for that as you go forward right there, right? Let us now just jump in and see what the other question was about. All right. So the other question says, the incomplete table below shows the results obtained by 200 boys and 250 girls on a Spanish examination. So this is a Spanish examination. We're dealing with boys, we're dealing with girls. As you could see there, you want to observe the table. You have grade 1, grade 2, grade 3, grade 4, grade 5. It's incomplete because they never filled out all the places. So we're just going to work the question based on what they're asking us. The first question says, a girl is chosen at random. Determine the probability that she received a grade 1. Like this question, it says a girl is chosen at random, not a student. I want you to be very cognizant of the difference. The question already said a girl is chosen at random. That means we're going to put this over the total number of girls. Now, if you don't remember what probability is, our probability it is our desired outcome over the total possibility. So it's the desired outcome over the total possibility. A girl is chosen at random. What is the probability that she obtained a grade 1? What's grade 1? Grade 1 is here, girl, 62. So we're talking about the probability, 62 out of how much? 250 girls. No, they didn't say break it down or anything. That answer is good, but we're going to try to break it down as best as possible. If I divide everything by 2, I'm going to get 31 over 125. Both of these answers are correct, all right? because they never specify that we need to reduce it. So 31 over 125 girls are 62 over 250 as a, remember, as a probability is not just to write the answer like this, right? Right? They probably give 2 marks for this. They give 1, that means you can't make an error. Because sometimes if they give 2 marks, they take the denominator differently from the numerator. But in this case, you have to give the entire answer for that 1. All right. Let's go. Let's see what the next question said. What percentage of the boys who took the exam got a grade 1, 2, 3? All right. Now, you're talking about grade 1 to 3. One has to take a look at the table. Where are the boys? And we're talking about grade 1 to 3. We're definitely seeing that we never had the number, but what we do have, we have 4 and 5, and we have the total. So I don't know who get grade 1, 2, or 3. I don't care. But from 1 to 3 can easily be found. We're going to add the 30 and the 8 and take it from the 200, and that is going to give us the total for 1 to 3 for boys. Let us get that first. So the total boys, the number of boys, all right, number of boys who get 1, 2, 3 is going to be this. 200 minus this plus this, right? So you're adding those and you're taking out of it. That's about 162, I believe, minus 38. That's 162. So what we have is 162 boys that actually get between grade 1 to grade 2. But the question wants you to represent this as a percentage, right? So it's a percentage of the boys. So we're talking about 162 over the 200 boys, multiply this by 100. Looks like about 81. All right, when you work this out, 2 to that, yeah. Use your calculator, take your time, break this down. We're going to get 81% of the boys actually got between grade 1 to grade 3. So there it is. Nice questions. Very straightforward, very simple. One, just read, look at it, and go, right? You read, you look at it, and you keep pushing, you keep going. Now, let us look at the other question. So the other question says, considering the standard deviation in the table below, compare the performance. All right, there is standard deviation that was given somewhere. Hold on. Okay, oh, it's in the table. Hold on. Standard deviation, oh, it's at the bottom. Okay, so boys is 8.2, girls is 6. So the standard deviation was actually, it's given in the table right here. So let us take a look. It's right here. So I'm going to write it down there, then we respond to the question. So 8.2 for boys and 6.3 for girls. Let's go here. So standard deviation, boys. I'm going to say SD for standard deviation, 8.2. And girls, SD standard deviation is 6.3. I'm just going to make sure that I didn't error in terms of that. Yeah, it's good. All right. Now, on your syllabus, you're not required to find standard deviation, but you're required at CSEC level, that is general level. For AdMath, you are required to do that, but for CSEC, you're required to understand what it means. So what is the standard deviation? The standard deviation really represents the spread of the score, how the score would have spread out between your range, where your highest and your lowest, how everybody would have performed, right? So what happened is when you have a bigger standard deviation, it means that the score spread out more between the range, right? So this basically then the score would have spread out more from your mean score. And when your standard deviation is smaller, it means that everybody kind of perform more closer to the mean score, basically. So we're talking about how much spread out. So the boy score spread out wider than the girl score is 1 mark. And this is all they require from you to say, is to tell that the boys would have a greater spread, right, than the girls. Or if you said the girls first, the girls' score would be less spread out compared to the boys. I could just, let me just type this. I could just say that the standard deviation deals with the spread of the scores from the mean. All right, so basically we could just say the spread of the scores. So I'll say since the boys had a larger SD, I'm just going to say SD for standard deviation, then it suggests that so we're talking about how they perform, that their performance was spread out more than that of the girls. That's all. So that will answer. It's a 1-mark question. So every time they give standard deviation, I promise you, the question will always be about, they'll give you the standard deviation, and then they're going to ask you the same question just to talk on it. It's always a 1-mark question, maybe 2. I don't remember if I've ever seen it for 2 though. But this is what you say all the time. You look at the 2 standard deviation. The bigger one means that the score is spread out more. It's like, it would have been like, let me just give a quick, all right, just a quick idea. So let us say that this is our central, which is our mean. The boys one might have spread out a little bit more. Like, let us say the boys spread from here to here. And then if this is maybe the boys. And then for the girls, if this were the mean, it's like the girls would have been closer to the mean, like they're closer to this. That's how we're saying. This is their X bar. This is the X bar. And I'm simply saying the boys would have spread out more. The girls would have performed closer to the mean compared to the boys. They are spread out a little bit more from here to here compared to the girls here and here. That's all it means. So that's what we're saying here, right? Right there. I hope you understand that, because I do realize that they keep asking this every now and then. So it can just pop in for a 1-mark right there. Wow. We're now into measurement. I like this question, right? All right, we're in measurement. And as you can see, the measurement questions mainly are, when the measurement questions come, it's solid geometry a lot. I'm not saying we don't get plane geometry, we do, but on a lesser extent, we do get solid geometry a lot, like these, all right? So let's jump into this question to see what it is saying. It says, diagram below, not drawn to scale, right? It's not drawn to scale. We're not going to try to look at anything and predict anything, all right? We're going with information. Shows an open cylindrical container made of metal with a circular base and a uniform thickness throughout, all right? Like that part, all right? The length of the container from the top of the outer bottom is 120. Okay, so it's given, it's 120 centi. And the interior, no, and the inner and outer radii are 14 and 15 respectively. Okay, so the thickness is 1. I'm seeing that coming out already, because the difference between the 2 radii is 1. So we're seeing that. All right, let's see what the first question wants. The first question says here, draw a cross-sectional view of the container. Okay, we're going to draw a cross-sectional view of the container showing the measurements of the inner and outer radii. All right, let me just drop a quick thing here. Here's a circle. I could just use my circle here. All right, so we're basically having an idea like that. Let me see if I could get 2 of them. This is it. All right, so that's 1. Let me put another one there. All right, so we basically have an idea like this. So this is the idea, basically, all right? And we have 2. So we're saying that the radius now would be, so we have, this is a short one. That's, I'm going to call that about 14, and maybe this one is about 15. Let me just drop it. There it is. There it is. All right, let's put on. So for the cross section, you're looking at it like the cross section. The cross section, we're seeing this is 14 cm, and this one here is 15 cm. That's the center right there. That's what. And you could see the difference. This between these two things here, it's 1 cm, right? And we're going to utilize that thickness, you know, when the questions start to unfold. So this is what they would have wanted you to draw as the cross section based on what the question asks. So you just want to draw that and then put on, you don't have to put on the 1. That is just for me to say, hey, look, they did say the thickness is 1, but we would have seen that when you put on 14 for the inner one and 15 for the outer radius, right? So basically, this representation would have given you, let me see how many marks. Let me go back to this. 2 marks, right? So we'll grab our 2 marks there. So that's our cross section right there, right? Let's go to the next question. It says, show that the capacity of the container is 73,304. When we talk about the capacity is the space that can be filled. So then you have to know that the capacity would be the small aspect, like in here. We're talking about if I'm supposed to throw some water, what is going to catch the water? So the catchment of the water would be done by that central region here. That means I'm going to have to focus on using the radius of 14. And then how far did it go? It didn't go all the way to the bottom. We could see that it stopped partway here, and the thickness is, so this is all right. So this is when you're going to apply the thickness throughout. This piece down the bottom here is 1 centimeter thick, same thickness. So we have 119 to work with. We're going to have to work with 119 for the height of the inner part because it never touches the ground. It lifted off the ground by 1 centimeter, which would have been the thickness that we were given here. It said that the thickness is uniform throughout, right? So having had that, what we're going to do now, can we find the capacity of the inner layer there, right? The inside cylinder. Let's go for that formula, right? Now, for you get the formula from CXC that the volume, well, I'm going to say capacity. We use it interchangeable. The capacity of a cylinder is always pi r square h, right? Now, let me look if they told me to use a certain thing as pi 22/7. So I was told to use 22/7 for pi. Now, remember, it's a small one we're dealing with where the radius is 14. So what we're putting on here is that it's going to be 22/7, which is pi, times r, which is 14 square, right? So if you want to put 14 times 14, that's fine, times the height, which is 119. Remember that it did not touch the ground, so you have to lift it off. I believe if we put these calculations together, we should get what they want. So it's going to be 22 times 14 times 14 times 119. Divide this by 7, and we're getting the answer to be 73,304 cm to the third. Remember, capacity is 3-dimensional space to be filled, so it is cube, right? Don't just write anything right there. So there it is. We would have proven that we got this. Just in case you're wondering where the 119 comes from, go back to the question. It did say the thickness is uniform throughout, which means that it lifts off the ground 1 centimeter. So if the entire height is 120, we ought to know that the small inside one stop at 119. All right. Let's go for the next question. We're coming down, we're going. All right, so the second question says, determine the volume of the material used to make the container. Now we're going to write a statement of truth here. Let me just drop the statement that I want to write. The statement that I want to write is that the material used is simply equal to, where is my equal sign? Hold on, guys. Material used is equal to the volume of the external, let me say the external volume. I could just compare. Let me use external and internal. So it's going to equal to the external and I'm going to take away the inner, whether you want to say capacity or volume, right? Right there. So in other words, then, if I find everything using 15, I'm going to use 15. So let's look back at it. I'm going to use 15 and 120, and I'm going to pluck out of it 73,304. And I'm going to be left with the material because this is actually an empty space. Space to be filled is an empty space, right? So let's get it. So basically then I'm going to go for that external idea. Now let's get it on. Let's get it. Let's grab that external volume. So this external volume is still given by pi r square h, where we want to make sure that, remember, so it's 22 over 7. R is now 15, remember? It's the big one now, we're going outside. And then the height is 120, not 190. So we have to be careful here. Now let's put this on our machine and work this out. 22 times 15 square times 120. That by 7. All right, so I'm getting some 84. I'm getting 84,857.14. All right, so I'm getting that. All right, so I'm getting this. And I stop at 1,4, right? To two decimal place there. That's what I did. So this is the external. But in a response to the question now, remember now, so this is CMQ. Remember we have the interior part already now. So we're talking about the material used will simply be this value that we have here. I'm going to take away the 73,304 from it. So outside minus inside, and I'm left with the raw material. So 84, 857.14 minus 73,304. I'm looking at somewhere 11,500 and right, I'm getting some 11,550. Let me see, 11,553.14, and this is CMQ. All right, so there we go. So you subtract the two, right? And then this is the material used. A nice 3-mark question. Whenever you get any question like this, the approach will be the same. You want to remember that if the material used is always taking the outside volume and you want to subtract the inside volume or capacity, because that's an empty space you're plucking out of the external idea, you will be left with whatever was used to make the thing. All right, so we could make a note of that as we go forward as well. All right, again, please like the video, share it to your friends right now. Everybody just stop, like the video, share it, drop a comment and subscribe to the channel if you have not yet done so. Let's go. This third, the D part of the question, so I think, so it says, given that the density of the material used to make the container is 2.2 gram per cm cube, determine the mass, right? Okay, determine the mass in kg of the empty container. All right? All right. So you want to determine the mass. We're talking about the material now. Talking about the material. So we're focusing on this 11,553. What did I get? 11,553.14. We're focusing on using this, right? Now, take a look, though. Take a look. Take a look at what we're dealing with. This is volume. We got a formula here, all right? Now, mass. Now, let us look. Density is equal. I'm just going to use D is equal to M over V. If I'm supposed to find, look, given that determine the mass, I want mass. I'm going to multiply both sides by V. All right? So density times volume give me mass. So they gave you the formula. You don't have to worry about this. They will not They will not ask you because it's not a physics exam. So you will definitely get it. So basically then what we're going to do is to look, we're working with common unit. So it is simply density, which is 2.2 gram per cm cube, which is this. And you're going to multiply that by the volume, which is 11,553.14. All right, let's see what we get for the mass. 11,553.14. Make sure that I'm not making any error. Times 2.2. All right, I'm getting some 25. So the mass is equal to 25,416.91, I believe. And this is gram. So you have to remember context now. This is gram. Now, here's the deal. Here's the deal. All right. So this is now gram. The question says in kilogram. Now remember that 1,000 kilo, my bad, 1,000 gram give you 1 single kilogram. So this conversion, they didn't give it to you. You got to remember these. Kilo mean 1,000. So 1,000 gram make a kilo. So all we're going to do now to convert this to what they want is to divide this by 1,000. Put this on your calculator, divide it by 1,000 straight up. It's going to give you, use your calculator, don't make an error, 25.4. All right, to 1 dp, 25.4 kilogram. So if I'm using 1 dp there, depends if I was using 2 dp or so, depends, right? So 25.4 kilogram. Remember, as soon as you work your problem, this is like the last. This is always going to do this. This is the last part. They want you to relax and do what you have to do, right? All right, let's go. Let's go, guys. We're going down, going. We're now at number 7. Number 7 is an observation question every year. Problem solving question where one has to look for patterns and sequence and then reproduce the idea, and then look at the table, look at the pattern, and then come up with ideas as you go. I'm going to try to express to you as best as possible how I think one has to respond in a way to be effective with these sort of questions, right? So this is going to be 10 marks that you should nail because they can't really trick you in this. Let us go for it. It says a sequence of figures is made from joining polygons with sides of unit length. The first 3 figures in the sequence are shown. We're looking at figure 1, figure 2, figure 3. And they always give you 3 and then said, hey guys, can you do the 4th one? So they want us to draw the 4th one. I'm just going to draw it here freehand, but in the exam, you could spend some time and draw it neat. When I say spend time, I don't mean waste time. So basically, you want to look at what's going on. We're going to have 4 of this. So basically, I'm just going to drop mine. 1. Well, on the inside, I'll have broken. So let me just do that. 2, 3, 4. Now close it down. And then these are dotted. So this is what you want to draw for your figure 4. Not a big deal. You look at what they have, you do this. And when you do that, you get through easily like that. They always look for the shape and to see if you use the normal things. There's 2 marks for this question. Sometimes marking these questions, you do realize that some people have the shape, but they never had the right amount. They still give you 1 mark. You know, you have the right amount, you didn't have the shape, you still get 1 mark. You do the both things correctly, you get the 2 marks. So you want to do both things correctly. Have the right shape of what you should have and have everything right there. So that is that. We get that. And then let's go to the table. Now the table is always there. They're always giving you information. You want to read it first, and then you want to jump in. All right. So let's say it says study the pattern of the numbers in each row of the table below. Each row relates to one of the figure in the sequence of figures on page 23. Some rows have not been included in the table. Complete the rows numbers 1, 2, and 3. So we're going to be dropping in values, right? We're going to be dropping in values here, there, 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 there. And as you could see, you get 1 mark for each. And these marks are knowledge, comprehension, and reasoning. So the knowledge one is what we're going to do right now. The comprehension one and the reasoning, they come after. But these that we're looking at are straight up knowledge. By looking at the pattern, we could fill out these right now, right? We could fill out these right now. So you want to take a look. Look, you're noticing this is 1, this is 1, this is 2, this is 2, this is 3, this is 3. So that means this is going to be a 6 already because you're seeing that pattern. And then there is always a +2 in the middle. Everything has a +2 here. That's a must. You're seeing that. Also, you take a look, you're noticing that, hey, 1, and then this is 2, this is 2, this is 4, this is 3, I'm seeing 6. Oh, that means this is 12. That's what you're telling me. So you're able to just look on the pattern right now, and we could get that. Now, another thing that you could look at, and I'm saying this part is very simple. We can look 5 plus 3, 8 plus 3. Oh, so +3. But what you want to do though, you want to make sure that you know what's going on because this is sort of +3 can't come here. It's not going to be 14 because we're not at figure 4. But what you could look at is this. Look, 1 plus 2 plus 2 is 5. 2 plus 4 plus 4 is 8. Really? 3 plus 2 plus 6 is 11. So that means I could add up these to know what the value here is. 6 plus 2, 8. All right. And then 8 plus this, 21. So you can eat 20, my bad, plus 12, 20. So you can easily look at the pattern. So this is a knowledge question where you could look at the pattern and get it, right? Now, let's take a look. What I would always advise people to do is why not fill out the nth? When you fill out this, it's gonna give you the what would call that formula that you could use to just furnish the table easily if you want. All right. So you want to drop that in so that you can deal with it and fill out stuff. So let's go get it. Let's take a look. That means if I see 6 and I'm seeing 6, I mean this is n. The +2 is always there. So the +2 is a must. But this number that comes at the back is 2 times the number in my first column. So that means this is 2n. Pattern. I'm just following the pattern. So it's going to be n plus 2 plus 2n. Like number 1, it said 1 plus 2 plus 2, then 2 plus 2 plus 4, 3 plus 2 plus 6. You're seeing the pattern. Anything I have here, it's double tier. Here, it's a double tier. Here, it's double there. You're seeing it. So if I have n, I'm going to have 2n. So it's not a big problem. We're going to use that to solve some problem. Let's keep going. Now, I'm going to show you how to get a pattern whenever there is a common, like the parameter here. You notice there's a common difference between consecutive terms. The common difference is 3. I'm just going to show you how to fill out the nth column whenever you see a common difference. And a lot of time there is a common difference. Look, 3. There's a common difference of 3. The moment that there is a common difference, the common difference multiplied by n. So this is already 3n. What you need to say to yourself is to use that to check off. In other words, 3 times 1 is 3. How did I get 5? You're like, wait, 3 times 1 plus 2 give me 5. All right, let's check the other one. 3, because the moment you have 3n in it, you can start doing this to know what is going to add or subtract from the 3n. So you're like, 3 times 2 is 6. 6 plus 2 give me 8. You try the last one. 3 times 3 is 9. I'm here. 9 plus 2 gives me 11. Then you're like, okay, so 3 times n plus 2 will take me from this column to this column. That's the point. So normally when you grab that information now when you fill out your nth columns or your nth row, you're now able to navigate easily with ease. So for this part, I'm going to take up the fact that I know that in that parameter, look where the parameter is. This is parameter up top. In that parameter column, 3n plus 2 can be used to find any value there. So we could say 3n plus 2 is 65. That is a way to get 65. 3 times n plus 2. So you can think backwards, or you could just solve this using your procedure. So I want to know what comes here. So I'm going to just take 2 from both sides. I'm solving. 3n is equal to 63. Then I divide by 3. Divide by 3. N is equal to 21. So this is suggesting that n has to be 21 in order for this to be 65. And that is what we're saying. We want to understand what we have such that we could apply ordinary algebraic skills to navigate your paper as you go through this exam. It's not a big deal, as I said to you. Relax, ease your way through it. Now, let's take a look now. How do I fill out this second column, which deals with the number of outer lines of the unit length? So we're dealing with this right about now. Remember that you will start off with the number in the figure. So figure 21, it's 21. There is always a 2, and then you're going to have to double the number at the end, which is 42, because 21 times 2 is 42. And that is what we expect you to have. You have gotten 8 marks already, 2 to complete this up here. So we got 2 marks to complete that. And we got 6 more marks to fill out these 6 spots. Now, there are 2 other questions that we're going to have to focus on. Oh, it's 1. All right. So a lot of times they drop this. This is one of the reasoning questions. And what you want to do with this reasoning question is that you want to apply yourself to it. So I'm just going to say again, if you're just coming on, like this video, share it with your friends, subscribe to the channel, right? You could be watching this all night for the exam tomorrow, right? So it says, show that no figure can have a parameter of 100, right? Show that no figure can have a parameter of 100. All you're going to do is to go where the parameter is. And you're going to take the parameter of 100 and you're going to try to find. So we're suggesting that they want us to show that there is no figure that has a parameter of 100. We saw where that there is a figure that could have a parameter of 65, right? Because at certain point you were seeing that we end up here, we divide by 3 in the end. So let's take a look to see what's going to happen. It's for us to see if we could find the end, which is a integer, or a matter of fact, it must be a positive integer. Let's go again. Take a look at your n. Your n values, it started at 1. 1, 2, 3, 4, 5, 6. So I'm saying focus on this column. These are my figures. They are not decimals. So at the end of the day, if I find n to be a decimal, it cannot work. It has to be a positive integer too. Can't be a negative number either. So let us take the key, which is 3n plus 2, which is the idea that defines parameter. Let it equal to what they say they want to see, which is 100 to our parameter right now. Now you're going to solve. We're going to subtract 2 from both sides. Come on, let's go. So this is 3n, which is now equal to 98. 3n is equal to 98. Let's divide this by 3, divide this by 3. Can 3 go into 98 without a remainder? I doubt that, but I'm going to do it. I'm seeing here where n is 32.6666, and it goes on to infinity. Obviously, we're seeing where n is not an integer. And because of that, it cannot be. So I'm saying right now, this is the answer, because so I'll say no. I could say no, n isn't, or I could say is not a positive integer. I got n to be a positive decimal number. All right. And that is a no. So it cannot be. So when they said show, it's for you to demonstrate that you're going to take up the concept or the idea of our parameter here, and then demonstrate that you cannot get yourself an integer that is positive. You did not get it, and you could just move on right now, because that is where it ends right there, right? So as you could see, when we work this out at the end of the day, we have to divide by 3. So if this number is not divisible by 3, then we're not going to end up getting a positive integer or what we call a whole thing, right? All right. So that is section 1, right? That is section 1. We have already completed certain aspect of the paper right there. So now let us now jump into section 2. We have 3 questions to go, guys. Stay with us. We're trying to complete this paper here. All right. So question 8 will always be titled algebra, relation, function, and graph, which means that they can send any graph there. So I'm just going to do a graph here. It is a quadratic graph, but that doesn't mean that you have to get a quadratic. Any graph comes there is under the idea of a graph. If not, any relation or function or any algebraic question they feel to give you. All right. So that's that is the label for this question. Let us now jump into it. The first question says here, number 8a, it says complete the table below for the function 3 plus 2x minus x squared. To complete this, all we're going to do is that we want to input. This is an input. My x values are input. I'm going to put them up here. My x values are input. And then the result of that would be our output, okay? So I'm going to input -2 in the function where x is, and whatever value I get will be my coordinates. It's going to be my ordered pair right there that matches with it. So let us go ahead. Firstly, I'm going to write this. F of x is 3 plus 2x minus x squared. So at this moment, I'm going to input. I'm going to do f of -2. So -2 will go where x is. As you could see, 2 times x, 2 times -2. Do not make the mistake here. My -2 is way different from this. A lot of people ignore that. You cannot. That is already in the math right here, but x is a -2. We don't want to make that error. So what we have here is 3 minus 4 minus 4, right? 3, did I? Hold on. Hold on. Plus 2, 2 is 4. Okay, minus 2, minus. All right, good. All right. All right, let's see what we get here. So what we have here is actually 3. This is a -5. This is -8. This gives me -5 right here. All right, there you go. That's my -5 right there, right? Let's keep going. So -5, so that's that one. Let's do the next one. I'm doing f of +2. So +2 is going to be 3 plus 2 times 2 right there. Then I'm going to minus 2 square. So this is going to give me 3 plus 4 minus 4. 7 minus 4, this is 3. So this value here is a 3. So here it is that we would have completed this. You'd have completed this by doing very simple, what we'll call function 1. We place an input. We evaluate the function at x equal -2 and x equal 2. We got those values, and now we're going to use it to help us to actually do the second part of the question. So there it is. You would have completed the table. Let us see what it is that they want here. So the question says, complete the grid in the table below. Okay, by plotting the points. We're going to plot the points. Let me try to minimize this. We're going to plot the points that we didn't get. All right. So they plotted 1, 2, 3, 4 for us. I think 4, 5. They plotted 5. Let us see how many. 1, 2, 3, 4, 5. So they plotted 5. So we're going to plot ours. We're going to plot -2 with -5 and 2 with 3. All right, let's go for that. -2 with -5. Let's plot those. So remember, we got -2, -5 is right here, -5 right here. So I'm plotting that. -2 with -5 is right here. And we actually got 2 with +3. I'm just putting it. So they did all of the work for us. We're going to plot right here. So right here. That's it. We're plotting right here and down there. And then we're supposed to draw our curve. All right. Let me see if I have it to draw it right there. All right, let me minimize this a little bit more to draw it. Give me a minute. Yeah, so I can see everything at once. All right, let me draw my curve here. I'm going to use my freehand. It may not be a nice curve, but I guess we'll all get the point. All right, you want to turn it right there. Want to come back down. 1 minute. Remember, remember your graph is a, what do I touch? Guys, give me a minute. I think I touched something wrong. Give me a minute. What is on the side here? Take it out. Okay. All right, I'm almost done. Remember, do not use a straight line to do this. Do not use a ruler. I've seen where people use ruler. Guys, I'm messing up my graph here with my screen. Hold on. I think I should get it now. All right, I think I just get it. On screen here is kind of killing me right now, but all right, there it is. I leave it like that. Okay. So there it is that we have our graph. I'm going to blow it up a little bit now. So you want to get something that looks like this, right? Blow it up a little bit. All right, good. So you want to get something that looks like that. You draw your graph and you're good to go. You follow the points, look at it. Do not use a ruler to do any curve, right? Rulers are used to do histograms, bar graph, line graph, but you're not, no cumulative frequency curve, no quadratic curves, right? Those are freehands. All right. So from that, no, we're good. And then let's see what else they want. So everybody should draw their thing. You should be drawing your thing right there. If you just log on to the channel, please like the channel, subscribe to the channel, share the video for others to come in. All right, we're going through some nice questions here. Let us see what the second question is now. All right, so this is what they want us to do now. Let's go get it. All right, so after completing that, and we drop our graph, all right, the question is saying to us now, use the graph, which is what we just have, to determine the coordinate of the maximum point. Now, maximum point suggests that you can see that the graph went up like that. So our maximum point is going to be right here at the apex, what we call the vertex of the graph. So the vertex is going to be that point right there. Let's go back to it. We could look. You could see the vertex. I'm going to put the vertex in pink. So my vertex is in pink right here, right there. So my vertex is actually 1 meet 4. 1, 4. So my vertex is at the point where 1 meets 4. Right here is a 1, 4. That's my vertex. So it's a very simple question. Straightforward. Your vertex is the highest or the lowest point. In this context, it's the highest because it's a maximum. So it's going to be where 1 meet 4. This is my x, this is my y. And be advised that that x value is at axis of symmetry as well. So just notes for clarification, just in case, right? All right. So we just handled that. Let's go to the next question. It says here, the range of values of x for which f of x is greater than 0. The range of values for x for which the y values that you saw were greater than 0. You could look at your graph here. Look at your graph, right? If I'm looking at my graph here, my 0, when my f of x is 0, it's my x-axis. When f of x is 0, let me put it in another color, blue. When f of x is 0, that is my x-axis right here. So the question is saying, we are looking at the x values that would have plotted the graph above that blue line. Now, the x values, I'm going to put them at a stopper here. Take a look. 1, 2. So these are my markers. So as I move from -1 towards +3, the graph was actually in the positive aspect. You're seeing the graph in this aspect as I move. As I move going this way, the graph is over the line. As I move, go that way, the graph is over. Look, the graph is up there. The graph is up there. So I'm just shading it for you to see that. As I move from -1 towards 3, from here to here, the graph was in the positive aspect, or it's greater than 0, because the x-axis is where f of x equals 0. And they wanted the part of it that was above the 0 line. I hope you're seeing what I'm saying and it is clearly expressed. No, I'm saying it started right here and it ended right here. So we're going to be standing between -1 and +3 and name it, right? So let's go on our number line right here. So imagine that I'm standing between, so I'm just showing you, there is a +3, there's a -1, and the graph went up, blah, blah, blah. We're dealing with this aspect. This is kind of ugly. Let me draw it a little better. Graph come down like that. And we are saying that from here to here, how do I describe all the x values here? I could say that, listen, x is less than +3, but it's greater than -1. That's it. You're done. You stand between the idea. In this case, it's going to be that interval from -1 to +3. But do remember what it is the question really want, right? So we're saying that f of x, right? F of x is greater than 0 right here, right here, right there, between that. And everybody saw that. Got 2 marks for that, right? Let's keep going. Let's keep going. Let us keep going. All right, let's see what else. What else? Let's go. More questions are coming up, as you can see, right? So we said C, right? C says, we want to do the gradient when f of x is equal to 1. When f of x is equal to 1, guys, we have to take into consideration this. So the gradient when f of x is equal to 1, my graph is a little bit ugly, but I'm going to grab it. Let me take off the shading from the graph and then answer this question, right? So when f of x is equal to 1, what is my slope? Now, remember that if you're going to do this, let me bring it to the other screen so we could just look at it properly. I'm going to take it off quickly. Let's bring it to this screen. All right, here it is. All right. And then we could quickly take a look at it right here, right here. So I'm saying we want to focus on when x is 1. Question says when x is 1. So this is when x is 1 right here. This is when x is 1. So when x is 1, it touched the graph all the way up here. So all I'm going to say, touch the graph right here. That's where it touched the graph. At the apex right there, right? At the apex. So I'm going to draw a line parallel to the x-axis. I'm just showing you what I want you to do. So the line that I'm going to drop here is parallel to the x-axis. Matter of fact, I want a big line. Give me a minute, guys. This is all right. So the line that I'm going to drop must be parallel to the x-axis, and it must touches the curve once. So it cannot cut the curve. It has to be a tangent. So I'm going to put it in purple, maybe red, maybe a red line. Let me see if a blue line is better. Blue. So if you look at that blue line up here, that line is a line that is parallel to the x-axis. We're talking about this. This is a tangent that we draw. All right. And you have to use a tangent to the curve. This is a tangent up here. And then because it's tangent and it's parallel to the x-axis, that means that it's an horizontal line. The gradient is 0. Because for all horizontal lines, our gradient is 0. Now, remember, for lines parallel to the x-axis, your slope, there is no slope. A slope is a slant. So we're saying at where x is 1, we touch the graph right there. So we make sure that we see where number 1 here touch the graph. It touches it right there. We do a tangent line to the curve at that point, right? It is at 1, 4, no problem. That's our x value right here. And then you need to understand that any horizontal line that you have, right, the slope for it is 0. So I'm not going to say the slope doesn't exist. It exists, it is 0. All right, because when it doesn't exist, it's undefined. So it is 0. We can define it. So we could tell here that the gradient at x equal 1 is 0. The gradient at x equal 1 is 0. All right. Let's see what else they have for us. All right. So this is a question that comes with some inequality. All right. So what we want to do is to quickly, it says, Mr. Thomas makes X bottles of juice and Y cakes each day. All right. X bottles of juice and Y cakes each day. So we want to say that X bottles of juice and Y cakes each day to supply his customers. He makes, watch this, to supply his customers, he makes at least, so we want to make sure at least 20 bottles of juice key and no more than 15 cakes, no problem, right? So there are the constraints, those are the ideas. Remember though, bottles of juice is X and cakes is Y. Write two inequality to represent this information. So we're talking about using these. When we have at least and no more than, we're going to have to include the bars underneath our thing. So the bars would have suggested that there is an equal into it. All right, this and no more, or this or more. That's the sort of idea. Now let us drop the first one. Let's focus on the one with X. So it did say here that Mr. Thomas make X bottles. So X bottles at least. If you say at least, it must be greater or equal to that number. That's our first one. So that's our first inequality. The bottles must be greater or equal to 20. Or we could say the X is greater than or equal to 20. Now, what about the cake? Y is for cake, and it says no more than. No more, that means you're less than or equal to it. So no more than 15. So no more than 15. Think about it. You're either 15 or a number less than 15. And that is how you want to make sure that you're thinking, relax, and go through. You would have picked up 2 marks there just to go through that, and we're good. Let us now jump on the other question. It says each day, Mr. Thomas used $160, $163 to make the bottles of juice and the cakes. All right. The cost, I think this is a cost. The cost to make a bottle of juice is $3.50. So juice is X. All right. And the cost to make the cake is, all right. So we have ideas here. Write an inequality to represent this information. In other words, then you're supposed to make some juice, make some cake, and you only have $163. So obviously you could spend up to $163 or less. So what we're saying is $3.50. So 350 times X. So 350X plus 525 Y. So in other words, then the number of bottles, because it's $3.50 per one, plus the number of cakes must be less than or equal to $163. In other words, I could spend less, all right, or that amount, I cannot go over that. So we want to put this together, 3.5 X plus 5.25Y is less than or equal to 163. That's based on what was said here. You're able to put it together. And then maybe it's a 2-mark question, and then you keep going, right? Let's keep going. Come on, let's go. Come on, let's get it. All right. The next question says, show that on any given day, right? On any given day, it is not possible for Mr. Thomas to make 50 bottles of juice and 12 cakes. All you're going to do is to work it out. Remember, Mr. Thomas only have $163 every day based on what he's doing. We want to note that. Now, remember that the juice costs $3.50. Cake cost, so this is X, this is Y, $5.25. All we're going to do is to work out and see if this money add up, right? So bottles of juice, 50. So 50 times 350. So we'll get 50 times, I'm getting $175 right there. So this would have cost him $175 right now. Cake is going to be, how many cakes? 12. 12 cakes at $5.25. Let's work that out. 12 times 5.25. Hold on. 12 times 5.25. Get my numbers right. I'm getting a $63 here for this. All right. Now, let's combine it because he's going to do this. So let us combine this. Total. 175 plus 63. Already, we can see that it's gone over because so this is $238. Now, this is what you would have done logically. You would know the price for the things based on what, and you know the money that this man has. Then no, you can now just close it down because your working is your voice. Your working is your voice. But you can conclude that you can just drop a line. I'm just going to drop a line for you as a conclusion here. I'm just going to say, since E only has 163 to spend, he cannot afford to do 50 bottles of juice. Where am I? Bottles of juice and 12 cakes on any given day. So we're drawing our conclusion based on our math, our figures that we put together, all right? We were able to do that. So since he only has $163 to spend, he cannot afford to do 50 bottles of juices well, I said juices. Hope you're good with that. And 12 cakes on any given day. And I'm just dropping that so you could see the whole idea behind it. And we're kicking it, going further. Come on, let's go. Come on, come on. That's number 8 finished. All right, number 9. Number 9 is geometry. We're going. We have number 9 and 10 to go. This is geometry and trigonometry. All right, so we could get various things on a geometry. You can get plane shapes here. You can get circle theorem here. And then trigonometry, you could get bearings, you could get elevation, depression. Those are the things that can come here. They give a circle here. So let us deal with the circle theorem. It said the diagram below, not drawn to scale, shows a circle. The points P, Q, R, T, and V are on the circumference of the circle right there. QRS is a straight line, all right? So QRS, let me just highlight it and remove it. QRS is a straight line right there. All right, and whenever they give you little clues, I am suggesting that you take it into consideration because they know why they're saying it. You're going to be using it as you try to furnish your diagram and so on. Angle PVR is 75. You're seeing it. It's there. And angle TRS is 60. It is also there. Now, let us see the questions that they're asking us to look at. Let us see the questions that they're asking us to look at. All right, in an effort to look at the questions without going back and forth, please allow me to take this diagram next door. And let me put this next door so I could flip between the two screens. All right, that's big enough so we could flip between. All right, flip again. All right, so we're good right there. All right, so here it is that we have the diagram. Let's go where the questions are, right? So the question says, let me see if I can get this a little bigger for now. It says, determine the value of each of the following angles, show detailed working where necessary, and give a reason. Now, I'm just going to say you pay attention to this. They did say give a reason to support your answer, not a reason for each step. Sometimes they do say give a reason for each step. This didn't say that. So we're only going to give one reason, right? If you want to give more than one, that's up to you. But this question is saying one reason is good enough for this question, all right? But I'm telling you that look out because sometimes they will ask you to give reasons for various steps, all right? Now, let's just go here. Now, what I would normally say here is that we're doing angle PTR. Let us look at angle PTR. I normally say identify PTR, identify PTR. And when you identify PTR, you want to look to see where there are. I'm going to try to tell you how I would do it because circle theorem is something that you got to give birth to. But I'm saying it's easier when you do this. Look where the angle, the 2 points where it was developed from to reach T. So I'm going to say to you, take a look. I'm going to mark it. It came from P and R. Now, I'm just giving one of the ways in which I approach it. I am suggesting that you look at P and R to see what else, which other angle came from P and R. Look. So you saw where this other angle at V came from P and R. Now, this should resonate something in you. It should allow you to think now to say, okay, what about these two angles? These two angles are in the same segment. So this is 75. Now, just in case somebody in the class who don't remember what a segment is, take a quick look. A segment is simply just to cut a cake bad. This is one segment here, and this is another segment. So the little one is the minor segment, and this is the major segment up here. We're noticing here that they didn't give us the line. They don't need to give you this line to show you how the segment was separated. You're supposed to know that a line is a imaginary thing. So you could see that the 75 up there, they do touch the circumference of the circle, and they're coming from the same endpoints of an imaginary chord, or they're standing on the same arc because so they're standing on the same arc and they did end up at the circumference in the same segment, and that is why they are equal. We call this angle in the same segment. So that should be enough clue there. I'm going to take off this because I need to decorate. I don't want to have too much stuff for the next question. So we could say that this angle is equal to 75 degrees, and my response is angle in the same segment are equal. And that's good enough. That's good enough. Based on how I see they look at the question, it's good enough to just say that. I know the definitions and the ideas, it's actually way more. But if you say this, they'll take it, right? All right. So we have angles in the same segment. That's what we picked up right there. So that's PTR is 75. I'm going to put 75 here. I'm going to decorate one of the diagram and leave one empty for other questions. All right. So we have 75 there. We got that. Let's go to the next one. So we're talking about TPQ. Let's go to TPQ. TPQ. So this is 75 here. Let me mark this. This is 75. We know that. TPQ. Mark TPQ. TPQ. Mark the angle. This. Mark the angle. That. All right. So upon seeing this, there are two ways I can approach this question. If I know certain stuff, I can do it. I could use straight angle and help me, as well as I could use the exterior angle of a cyclic quad is equal to its interior opposite. So I'm going to identify the cyclic quad first. The cyclic quad is P, T, R, Q. That's a cyclic quadrilateral, right? So as you could see, the 4 points are on the circumference, right? Now I'm going to just draw out this just for clarity so that everybody can actually see definitely that that shape is a cyclic quadrilateral. Now, how do we respond to this question? There are two ways. I'm going to show you the simplest walk into the answer way. So watch this. One of the way you could have done it is to come on the inside here. If I know that angle there, these two angles are supplementary, which means that they add to give 180 degrees. So I'm saying solution one is that I could first find the angle at R right there. So that angle at R, I could say 180 minus 60. Why? Because it's a straight line QRS. So 120 is this angle here on the inside. Now, remember, no, that's not the answer to the question. I need this angle here, which is a TPQ, right? So I need TPQ. Now, if you take a look at TPQ and the angle at R, they are opposite angles in a cyclic quad. They do add to give 180 degrees. So it's going to be 180 minus 120 degrees here. And then the answer for this is 60 degrees. Now, if you do this, you could say more than one thing. You could have said opposite angles. I'm going to type this. You could say this if you want. So this is one way you could do. You could have said opposite angle in a cyclic quad opposite angles are equal. No, Marcel, my bad. Opposite angles of cyclic quad add to make 180 degrees. All right. So that's what you could put with this if you did it that way, right? You put that with it if you did it that way. You never had to do it that way. You could have gone straight to the answer. So solution two. I'll give you solution two right now, and then we go. Solution two, I don't need to come inside, right? And here goes. Hold on. I need to get my rubber up. All right. All right. I'm going to stay on the outside to deal with this one. The moment I realize that I have a cyclic quadrilateral, right? And we do acknowledge that this 60 degrees here could take me to the answer. There is a rule that says the exterior angle, take a look. This is an exterior angle of the cyclic quad. The exterior angle of a cyclic quad is equal to its interior's opposite. Let's go again. The exterior angle of a cyclic quad is equal to its interior, ownership, its interior. So this is the interior for it right here. That's its interiors. So its interiors opposite, which is diagonally across there, 60 degrees. So if I just write 60 degrees for my answer, then I have to say this. I have to say this, the exterior angle of a cyclic quad J lateral is equal to its interiors is interior opposite. Yep. So with that said, you can see why we could just call it 60 with this reason though. The exterior angle of a cyclic quadrilateral is equal to its interiors opposite. That's the only way you could do it. So you could say this or say that, right? And that's this. This is 60 right here. Both ways we get 60. So the reasons have to come with your working though. So if I work it out like the solution one, I have to give that reason. And if I work it out like solution two, I have to give this reason. Okay. So basically we're saying that take a look at it. And it's a nice vibe when you're working these. All right, allow me to take off these and we're gonna go for another question. All right, let me clean this up. Let me clean this up. This was 60. This is 75. All right, so we have tools going on. Let's go for the questions again. All right, so we got that said. So this says what we want to do is that there's obtuse angle POR where O is the center. So we're going to create this POR where O is the center. We are going to create that. All right, so we're going to go back to it, POR. Obviously, we didn't get O, but they say create this POR now, and O is the center. So I am going to say, all right, I'm going to call, here's my center. So I'm going to say, call this O. And then I'm going to just create this quickly. Bear with me. So I'm going to create mine. Drop in this here. So this question is kind of weird because it's saying, hey, you're going to create this. So POR, and they're saying, this is what you need to tell us. Now, again, I'm going to do the same thing that I do every time. Whenever I have a angle to deal with, I would say, where did the angle develop from? POR was developed from P and R. Take a look. It was developed from P and R. And then I asked myself, which other angle was developed from this same spot? Take a look. I'm seeing this to use to help me. Or I did say or because I can use this because it came from it as well. That means it came from the same spot where P and R. So these came from P and R. I'm saying when you look at it, this is how I want you to think, right? It came from P and R. So now you're going to say, but what? No, this should actually nudge you to think because this is the idea. Will it nudge you to think that, hey, oh, I have an angle at the center and there's an angle at the circumference. If you don't remember anything, then you can't. But you are supposed to study the rules because there is one that says an angle at the center, right? If you're standing at the same endpoints of the same arc or this imaginary card that I'm going to put in now, if you're standing on the endpoint of it, then the angle at the center is going to be 2 times the angle at the circumference here. So that means for this angle, I need to say 75 times 2 is going to be 150. This is 150 degrees. Angle at the center is 2 times the angle at the circumference, or angle at the circumference is half angle at the center. And with that said, we were able to manipulate this, get it going. So that is what you should do right there. I would have just said 75 times 2, and this give me 150 degrees. And I'll say center angle is twice that at the circumference. And I'm just dropping this as a summary because I just said it. Providing they're standing on the same endpoints of the card or standing on the same arc. That's the context for it. So it's 150 and we keep going. All right, so for this one now, we're stepping out of the geometry. We're now stepping into trigonometry. So we're going into triangles and there it is. We're looking at our first trigs here. It says here, a person at the top of a lighthouse, right? TP sees 2 ships, S1 and S2, approaching the coast as illustrated in the diagram. The angle of depression, 12 degrees and 20 degrees respectively. All right, we're seeing that. All right, good. The ship are actually 110 apart. All right, so I'm going to put on some little labeling on my diagram. I'm going to put on some labeling. I'm going to put 110 right here because I was told that, right? All right, so complete the diagram. Remember though, there are 2 angles, and because it's depression angle, remember depression angle have to come from up top and my horizontal line up here. See it here? This is my horizontal line that I have up here. And then I have another angle here. So be advised, the bigger one is 20. So this has to be the bigger one, and this has to be the smaller version. So you want to put the angles in context in terms of the values. Don't mix them up, right? You don't want to put the big one where the small one is, all right? So there it is now. We have this, right? And what do they want from us? So we label. Those are the instructions. Those are the information we have. We put it on, and then now it's time to answer the question. The first question says, determine to the nearest meter, which means that we're going to give our answer to the nearest whole number. Nearest meter is going to be a whole number when we're ready for it. The distance TS between the distance TS2, all right, between the top of the lighthouse and the ship 2. Oh, all right. I'm going to highlight this for you. We want the distance TS2, this. They want that. All right, not a big deal, but you're going to have to put things into context now, all right? Put what you know. So let us take a look at what we have here. Let me change the color of the marker. Let me use a blue dot. All right, This little angle between here is 8. You could see here, if I take the 20 minus the 12, I'm going to get a difference of 8 between. This little thing here is 8 right here. I need it because I'm seeing where the opposite to it is 110. Look at it. Let's take a look. I'm going to draw the line. This is 110. It's going to help me somehow to do something, right? Now, another thing that I know is that this angle here, even though I'm not going to use this one here, this is 12, not going to use this, but I'm going to use this one now, which is, oh, but I could use it too. Yeah, could use any one of them. This is also 20. So I could use the angles. I could use so many things right here. So take a look at this. So when I bring these angles down here, right? Then this angle here is 160 degrees because 180 for a straight angle, take 20, it's going to give me 160 degrees right here. I want the side opposite to it. So now I'm thinking the sine rule, because the sine rule says if I have an angle, right, and the side opposite to it, if I relate them, they're always going to be equal. What am I saying? I'm saying that I'm going to take 110 over the sine of 8 degrees, and it is going to equal to TS, this is TS2, over the sine of the angle 160. Take a look now. Take a look now. We're talking about this coming here and the 160 to what I want. So remember with the sine rule, you have to use sides and their opposite angles, right? Any two pair where you have the two known ones and then one of the other, we can manipulate the ideas and we could go. All right. So let us get that out the way. All right. So we're just gonna say no. Let me just work this out. Come on, let's work this out. I'm gonna just employ cross multiplication. So multiply these. So I'm gonna say the sine of 8 degrees times TS2 is equal to 110 times the sine of 160. All right. So you're seeing that at the end of the day, I'm going to have to divide by the sine of 8 degrees. So if you put this on your calculator, make sure your calculator is in degrees. Let's put it on it. We're talking about 110 times the sine of 160, and we want to divide that by the sine of 8 degrees. Let me see what I get. I'm getting 270. All right, this is what I really get. I get 270.3. 0.33. However, the question says the nearest meter, which is the nearest whole number. So right here, and then I look here. So this is approximately 270 kilometers right here. So it was rounded off 270. And there we go. You focus on the questions, look at what you have. If it is not a right triangle where you are, then it's sine or cosine only. Nothing else can work. If it is a right angle where you are, then you know you deal with SOHCAHTOA or Pythagorean theorem, depending on what you're dealing with. All right. So in this case, it wasn't a right triangle. So I'm just going to highlight the triangle that we used just now. We actually use this triangle to solve the problem. This. So if I should drop it on the side for you to see, this is 8. This is 160. This is 110. We needed X. That's what we're saying. So with the sine rule, we were able to say opposite sides and its angle. We were able to use that. And since we had 4 things dealing with and we got 3 of them, we were simply able to solve that problem using that. All right. So that's just one of the ways that we could have get around that. Let us go to the next question to see what we have. The height of the lighthouse, TS, the height of the lighthouse, TS, right? So we want to look at the height of the lighthouse. I probably take this. I'm going to take this question next door. I'm going to put on my 270 on this first. This is 270 km here. Take off this X. All right, so the height. I might not even need these. Hold on. I'll put them on when I go up there. Give me a second, let me copy this. All right, if you're just coming, please like and share right now as we go. Hold on, let me push the button. All right, let's go get it. We're ready. All right. Let me see if I could bounce between this and the question. Let me go where the question is now. Right here. All right. So, all right. So we could look at the diagram here and then do it here. All right, good. So here's the deal. We want to find the height of the lighthouse, right? So you're seeing the height of the lighthouse is over here, right? Let me pull this down a little bit first. The height of the lighthouse is TB. Just think about it. The height of the lighthouse is TB. Let me highlight the triangle that I want us to focus on. Take a look. It's a right triangle. Ignore unnecessary things that you're not using. We're going to use this. And you see this 12 degrees is going to help us right now. This angle here is 12 degrees. We're going to use that, right? And we're going to use this hypotenuse here. And then we are going to go to what they want, which is the opposite to the angle right here. So because it's a right triangle, I'm going to have to think of ka, tawa. And the sign is going to deal with opposite and hypotenuse. This is the hypotenuse. So then, in an effort to find the height TB, the sine of the 12 degrees will equal to the opposite side, which is TB, over the hypotenuse side, which is 270. Right? So we started off like that, all right, which is 270. So in this context now, all we're going to do is to multiply both sides by 270. So 270 times the sine of 12 degrees is going to give me the height, TB. And I'm getting some 56. 56.1. I'm going to double check to see if, hold on. I don't know if I think, let me see if it's kilometer or meter. Hold on. Because I'm going to double check. Oh, it's meters. All right, my bad. Because even here, I wrote kilometer here. So I'm just going to fix it because I wrote km here. Let me fix it for us. Apologize for that. So I wrote m. All right, so it's km. So I even put km on these too. All right, not bad. Fixing this. I fix it when I see it. I didn't realize I wrote that. Making up my own thing, right? All righty. So we just work on TB to B. So, all right. So remember, this is meters. So it is 56.1 meter, not kilometer, guys. All right. So this was meters right here. This was also meter as well. All right. If the instruction still went for that, it would have been 56. So let me look if it's to the nearest meter. Okay, so all our answers should be to the nearest meter. It means that I have to submit 56 meter, right? So even though we got 56 point something, all of these questions that we're doing must round it off to the nearest meter, and then that's it, right? So it's 56 meters for that question. Question 10, last question of the day. We're wrapping it up. All right, it says that the matrices are given as follows, right? So we have -1, 2, 0, 5 for P, and Q is AB, and R is 11, 15. Using a calculation to support your answer, explain whether matrix P is singular or a non-singular matrix. All right, what's the concept of a singular matrix? A singular matrix determinant is 0. That's the concept. If you have a singular matrix, the determinant is 0. So we're going to try to find the determinant. And if it is 0, fine. So matrix P is -1, 2, 0, 5. If you're going to find the determinant is going to be the product of the main diagonal, which is this that I put in blue, And you're going to subtract the product of the other diagonal, the non-leading diagonal, right? So basically then, what we're saying is for it to be the determinant of P, let's do -1 times 5 minus 0 times 2. -5 minus 0 is -5. Now, since this -5 is not 0, remember, so you could write that since the determinant P is not equal to 0, then matrix P is non-singular. That's it. So this is based on whether or not you know what a singular matrix is. So if you know what a singular matrix is, you're expected to put it together. If you don't know, you just don't know. But I guess tonight is it, because we're simply saying that a singular matrix, as you could see, the determinant must be equal to 0. So since this one was not equal to 0, then we can say that it is not a singular matrix, right? All right, with that said, we could go to the next question. The next question says, calculate the, want to calculate, no, given that PQ is equal to R, determine the values of A and B. So we're going to go back for P and Q. So PQ, so let me write P and Q here. P was -1, 0, -1, 2, and then we have 0 with 5. So this is P. Q is AB. And it is equal to R, but R, I think, is 11, 15. All right, so we want to determine that. This is like equated matrices. So what we're gonna do is to carry out our row by column. So let us highlight the rows: row 1, row 2, column 1. So row 1, row 2, column 1, right? So what I'm gonna get here is I'm gonna get row 1 times column 1, and then row 2 times column 1. This is what we're gonna do, right? So let's do it. So it's going to be -1. Watch this. -1 times A plus 2 times B. So that's row 1, column 1. -1 times A plus 2 times B. Then it's going to be 0 times, so row 2, column 1, 0 times A plus 5 times B. I'm going to fix it up, and this is equal to 11, 15 over here. So this is -A plus 2B equal 11. And underneath that we have, let me write it up properly. And then we have 0 times A, so we have 5B equal to 15. All right, let me write out the matrix right properly for me, please. Come back, pencil. 5B, 15. Here it is. Now we can equate them. So in this case, we can equate the ideas, right? So we could write out the thing. Take a look. -A plus 2B is 11. Also, 5B is equal to 15. I'm solving this problem. I'm going to solve this one first. I'm not going to do it a simultaneous equation or anything. So I get 5B is equal to 15. I'm going to find B, divide both sides by 5. B is equal to 3. So now I know that B is 3. I can substitute B in the other one. For we have -A plus 2B equal 11. So now I'm going to substitute the fact that I know that B is 3. Boom. So -A plus 5 is equal 11 minus 5 from both sides. So -A is equal to 6. That means A is equal to -6. You could multiply everything by -1 to change it around, right? Since -A was equal to 6, you could just say A is equal to the -6. You could just flip it around. It's not a big deal. Oh, 5. Why I'm saying this is 5, guys. All right, let me fix this. This is 6. Hold on. Hold on. I wrote 5. I wrote 5. It should have written 6. Hold on. This is 6 right here. My bad. I subtract 6. I subtract 6. So negative a is equal to 5. And then if you multiply everything by negative 1, then a is equal to negative 5. Apologize for that. So a is equal to negative 5. And then b is equal to 3. Here are our solutions. And there it is. Doesn't get harder than that, basically. All right. All right. So I quickly fix that. All right. All right. There it is. There it is. All right. Now let us now keep going. So that's the matrix part. It says now the third part says, state the reason why matrix PQ is not possible. Right? Let's write them down. I normally write them down. QP. Q is A, B, and P is negative 1, 2, 0, 5. Let me write it. This is Q, this is P. What's the order of this matrix? This is a 2 by 1 matrix, and the order of this is a 2 by 2 matrix. There are many ways you could state things to them mathematically. If the two inner numbers here are not the same, it's a no. So this is the guarantee here. These two inner numbers, they did not match, so it is no, it cannot work. Now remember that this is row, and this is column. This is row, this is column. So based on what I see, if you write this and say no right here, they'll give you the mark. And if you don't want to do that, you could say the column from the first matrix, the number of, let me write this. You can write this. You can either do the mathematical thing here. That works. And if you don't feel like you want to do this, you have to say this. The number of columns in the first matrix is not equal to the number of rows in the second matrix. That is why it doesn't work. So it doesn't work because the number of columns in the first matrix is not equal to the number of rows in the second matrix. So it's either you're going to state this, or you could just write out 2, 1, 2 by 1, and then 2 by 2 and say no in the middle, circle it, and I said no. They work with that. I've seen that. All right. All right. So matrix is finished. Vectors, and last, we're at the last. Okay, let's see what's going on for this vector question here. It says here, all right, so I'm going to label as I go. It says OABC is a parallelogram. OA, this is B, hold on. This is B here, and this is C. It is a parallelogram. That means this is parallel to this, and this is parallel to that. All right, it's a parallelogram. All right. All right, let's see what they're saying here. So I put on the labels. It says X is the midpoint of AB. So AB here, we're going to mark this. This is X. X is the midpoint of AB, right? And Y is the midpoint of BC. Where's BC? Right here. This is Y, marking these spots. All right, no problem. And midpoint is halfway. O, all right, so OR, so we're going to be careful now with our direction. So the direction from O to R, O to A, should say, is R. O to A is R. O to C is X, is S. So arrows from O moving to C, they call this S. All right. So we have O to A, which is R, and then O to C is S. Let us see what else they, what else. Are we ready now? It says complete, and I'll complete the diagram below to represent all the information that we actually were given, right? So we drop those on, and then because you told me that, I know that this is the same as this, and this is the same as this. Like, I know that, right? So information given, we're able to do those based on what we're given. Because if it is the midpoint, then those would be congruent or they're equal. Let's see the first question. So the first question says, given, well, the second, we just did one. The second one says, given that OX plus OY is equal to K, in the bracket we have R plus S, where K is a constant, using a vector method to find the value of K. All right, the value of K. So OS, they told us that take a look at what they said. They said OX, all right, plus OY is equal to this. Let's do it. So I'm going to find OX. So how do I find from O to X? OX is to travel from O to A, then from A to X. Let me do that right now. All right? So that is OX. So I'm going in the same direction for OA. It's R plus, remember now that AX is a half of AB. AB is the same as OC because it's a parallelogram. All right? So basically then, AX is actually a half S because AB is equal to OC, which is equal to S, because they did say it's a parallelogram, so they are the same. So basically now AX is a half of S. So we have R plus half S. We're good. All right. All right. So we have that part. Let's go for the next part. So for the next part now, we wanna go to OY. Let me write it here. OY is from O to C plus C to Y. Again, we got OC. We know OC from here. We know that this is S. But CY, we were told that Y is the middle. So C to Y is a half of C to B. And this means that it is a half of CB. CB is OA. Look, OA is parallel to CB. Same direction. So it's a half S. Half R. I said S. Half R. R. Write it back. This is R, right? So this is a half of R. So CY is a half of R. Now, in order to solve the problem, we are supposed to do this. OX plus OY is equal to this. Let's do it. I'm not even going to think about it. I'm just going to do it, and then I look. So OS is this. OX is that. So R plus, right? So R plus half S plus, right? Plus this, which is S plus half R. This should give us K and then R plus S. So that's the idea. Let's put it together. I see like terms, I feel good. I'm going to put the R's in front. R, half R. I'm going to color code ideas. Half S, 1S. Let's put it together. 1R plus half R is 1.5 R. So if you want to call 1.5 or 3 over 2, it's up to you. So if you want to say 3 over 2, because 3 over 2 is 1.5 R plus half S plus 1 more S is 1.5 S. You can say 3 over 2 S if you want. All right. And this is still equal to K R plus S. Take a look. Don't you see the common factor here? Common factor is 3 over 2. Now I'm going to factorize out that to be my K. Take a look. So I'm going to factorize out 3 over 2 here. And then in bracket, I'm going to have R plus S. And then I'm going to let it equal to this still because I am looking at what they want. Take a good look now. All right. When you take a look, this is this, right? You're seeing that. You're seeing that, which means that all I'm gonna do, let me highlight this because I'm seeing that it didn't. So you're seeing that R plus S is R plus S. Therefore, we can say K must be 3 over 2. Done. Right there. We're seeing that K is actually 3 over 2. And that is how you do your vector questions. Not a big deal. One has to just relax, look, and put it through. I will say to you, all the best in your exams. All the best, right? Oh, let me look if there's another question. I don't. Is there another one? We are. Oh, we're done. All right, that's where it stops. That's the last question. So all the best in your exam tomorrow. And tomorrow I go live with the solutions. I go live with solutions. All right, tomorrow. All right, so tomorrow evening, when you're done your test and you come home, you could look out. I will go live with your solutions. Take care of yourself. It was nice for you to be here. Like the channel, share the video still. A lot of people might miss it and they still need to actually start going through. This is actually a good synopsis of what the exam is going to be like, the major topics and things that you should look for. See you another time, right? Remember, like the video, share it, and subscribe to the channel. See you next time.